Process Control webinar on wireless control technology. So I'm Sabina Zir, and I'll be the moderator for today. And I currently work at OPG as a business analyst. So today we're joined around by 30 people. And before we move on, I just want to review some housekeeping rules. So all questions will be done through the live Q&A function, so it won't be in the chat, but this function you can find in the top right ribbon of the Teams meeting. And if you see a question you really like within that Q&A, just be sure to upvote like that question so that you know that we're more likely going to see it and we're more likely going to ask. So for today's agenda, we'll just start with the land acknowledgement, followed by a bit of background on NAYGN Durham. After this, I will introduce today's speakers and turn the floor over to them to deliver the presentation they have prepared for us today. And then finally, we'll wrap up today's session with a 15-minute Q&A based on the questions submitted during the presentation. So before we start our meeting, we would just like to start by acknowledging that we are meeting on land that has been inhabited by the Indigenous peoples from the beginning. We would also like to acknowledge that many different treaties and traditional territories that OPG structures are situated on across the province. The land on which we gather is the traditional territory of the Mississauga Anishinaabe. Land acknowledgement is just one small but important step in a lifelong commitment to learning and action towards reconciliation. We encourage everyone to learn more about the important history of our Indigenous people. September 30th marks the National Day for Truth and Reconciliation, and it is important for each of us to remain committed to the ongoing process of truth and reconciliation with Indigenous peoples every day of the year. So just a short intro to the NAYGN Durham chapter. So this was created in 2008. The NAYGN Durham provides opportunities for a young generation of nuclear enthusiasts in the Durham region to develop leadership, professional skills, create lifelong connections, engage and inform the public, and inspire today's nuclear technology professionals to meet the challenges of the 21st century. So also a fun fact, Lakeside is a sponsor and a supporter of NAYGN Durham, playing a pivotal role in empowering our initiatives. So their generous funding enables us to bring our activities to life, fostering meaningful engagement and driving impactful change within our community. So like a huge shout out and thank you to Lakeside. And in regards to events and all that, NAYGN Durham has several teams hosting events for networking, professional development, community outreach, and public relations and education. So we have an event for Take Your Parents to Work Day event taking place on Thursday, October 9th at the Pickering Nuclear Information Center, and also a fireside chat with Ryan Howard, who is the VP of DNNP, on Thursday, October 9th at CHQ. So our first presenter, Roland Smith, he is a technical specialist. So Roland graduated from St. Lawrence College in Kingston with the Instrumentation Engineering Technician Diploma in 1989, held an account manager position with both Rosemount Instruments Limited Canada and Lakeside Process Controls in the Southwestern Ontario region in Sarnia. From 1998 to 2016, he changed roles in 2016 to a technical specialist supporting pressure, temperature flow, level, and wireless product portfolios, providing technical support for end users as well as support for Lakeside's internal teams. And then the next presenter is Michael Kwong, who is the Nuclear Account Manager at Lakeside Process Controls, supporting Ontario Power Generation with trouble inquiries and project execution. So since joining Lakeside in 2012, he has contributed to major initiatives such as the Darlington LRV, Darlington Large Mod TCVs, and is currently working on assistance for the Pickering refurbishment project. Michael holds a chemical engineering degree from Queen's University and is actively involved with NAYGN Durham and Marigold Hospice Care. So huge welcome to y'all, and I will now turn it to the Lakeside folks to take over the screen.
So Roland's going to share his screen. Hi, everybody. Just while he's doing that, I'll just introduce myself again. I'm Michael Kwong. I've been working, as Sube said, for Lakeside for over 13 years now. And you may have seen me, that's why I'm sharing the screen, most recently at the Blue Jays NAYGN game, as well as I'm on site at Pickering, Darlington, and various other OPG locations every month or every few weeks. So if you do see me, feel free to say hi. I basically am the single point of contact at Lakeside for all our business, which we're going to talk about wireless measurement here today, but we also do all kinds of other things in automation, such as control valves, relief valves, and mechanical services. So take it away, Roland.
Thanks, Mike. Thanks for the introduction there. It's nice to be back in front of you folks, not directly, but I did a pressure and temperature similar presentation a number of years ago. So it's nice to be back harassing you, presenting to you today. And I got a lot of slides here. I did want to make one comment. I like the bring your parents to work idea. I think that's fantastic because things are changing drastically out there, not only in the nuclear industry, but industry in general. So I think that's a wonderful idea, and I think we should implement that at Lakeside. I think that'd be a lot of fun. So I'll get on with today. Wireless HART has been around for quite a while, so it's nothing really new. We'll get into an agenda. What is wireless HART? The basics of it. The network structure includes gateways and a little bit on security. If I skip anything today because we're tight on time, it will be on the security piece on the gateway side. And then devices and some of our key applications and some of our overview supporting software, if you will, to make your data collection and analysis much easier when you get into the wireless world. So we'll get right into it. Like I mentioned, wireless HART has been around for a long time. It's since 2008 we saw our first wireless product. So we've been doing this for quite a long time. It's an open standard. IEC 62591 is an open standard, so it's open for other manufacturers to provide wireless HART products that will join seamlessly to different hosts that are out there. So the whole protocol was designed for interoperability between different manufacturers and different hosts. As I mentioned, low power, fault tolerant. We'll go through that on how that works. Cybersecurity, and it sits on the unlicensed 2.4 gigahertz spectrum. The reason for that is, as it says on the slide there, just for global consistency. For the most part, that 2.4 gigahertz spectrum is an unlicensed throughout the world. There are a few spots that isn't the case, but for the large majority of the world areas, that 2.4 is an unlicensed spectrum. So it makes it easy to implement, nothing special there. And these are all through the field comm, much like our wired HART products, device drivers, and so forth are all through the same field comm organization. As I mentioned, we've had a start on this back in 2008. We're well into almost 20 years of product development and enhancements. We continue to add new products to our portfolio as we go. So pervasive sensing, as we call it in the Emerson world, is ever expanding with new products, even coming on board this year with a new wireless temperature transmitter and a new wireless non-contacting radar device as well. So new products, new applications are coming up on a fairly consistent basis as we move forward. Another snapshot on that. So we're 17 years into this. Bunch of different products available, so 60 plus. So we have a very deep and wide breadth of product and applications throughout our wireless portfolio. A little bit on how it works. One of the key things is we needed a wireless network to work in industrial environments, and what I mean by that is high RFI, high EMI surroundings with dense infrastructure. In some cases, with tanks and pumps and motors and whatever else you can imagine in a plant industrial environment. So this protocol is made to work in the real plant life. Every device is a repeater, which helps form a self-organizing, self-healing mesh network. And what I mean by that is every device is a repeater. So it will automatically try and reach the antenna or the gateway antenna to bring back its device. In the event that it can't, it will develop an alternate route to get its data back. What I mean is it'll bounce through another device up to 7 times deep to get that data back to the gateway in a healthy, reliable, robust field network. So that self-organizing aspect of our devices is key. There's no configuration parameters where we need to tell one device to talk to another and in essence get its way back to the gateway. It self-organizes. All we do is install, plug in the battery, and as you see here, a key component of the infrastructure or the initial commissioning is entering the network ID and the join key. That join key and network ID can be user selectable or configured on your own, and you can enter your own network ID and join key. So there's that's the key component to add a device to the network. It's really very simple. We use our Trex or some of our software to install that network ID and join key into the device. So just to review, WiHart addresses some of the major concerns that you can well imagine in wireless infrastructure. Battery life, reliability, security. Are you able to secure or scale your network? Are you able to easily add a device and help that network scenario? So interoperability is important. Range, distance. So we'll go into a little bit on what you see on the different antenna types and how we tackle those scenarios as they arise. And of course, update rate. So update rate is important because no different than in our everyday lives with our other wireless products. The faster you're sending the data, the faster you're going to eat up your battery life. So that update rate or burst rate, as we sometimes refer it to, is configurable, and it definitely reflects, can impact the life expectancy of our power modules. So a little bit on the antennas. So you can see we have a different mishmash of antennas and configurations for both distance and to handle certain infrastructure scenarios. More dense, more open areas, that type of thing, where we mix and match antennas as required to handle those different scenarios. We have some devices with a copolymer housing that you see at the top there that has an internal antenna. You notice it doesn't have a black antenna sticking out the top. And for some of our devices, you'll see at the bottom, we actually have a remote high gain antenna. The idea would be that is if it's down at grade level and we have to go 1 kilometer or more, we can provide a remote high gain antenna on that device. We can't do it for every device, but for a large part of our portfolio, we can add that high gain antenna and get you back even further. I mentioned power modules. So we typically have 3 different types of power modules in our portfolio. The green modules you see on the left are usually for our copolymer housing devices, 708, 3051, 2051, 248 temperature transmitter, for example. On the right-hand side, you see our black power module that are used in our aluminum housing devices. And then the blue power module is something that has been developed for some of our power-hungry devices. For the most part, that's our 9420 vibration transmitter. It does online vibration analysis and sends the spectrum back to the gateway. So there's a lot of data at times that can eat up the power in that data transmission. So this blue power module is predominantly for that device specifically. We have an online estimator. A very common question that gets thrown to Lakeside is how long our power modules will work. So we have an online estimator to help with that. But you can see on this screen, there's a little bit of estimate. So burst rate or update rate plays a key part, as well as ambient temperature. So in our northern climates, we can enter an average ambient temperature of, say, 0 degrees Celsius in that calculator, enter the update rate. So you can see the differences is even on our 702 discrete, the very bottom one here. Whereas if we're at a 1 minute rate, we have a 8 to 10 year life. As that burst rate or update rate gets more on a more frequent basis, we drop down to under basically 2 years or so for a power module, which is still pretty good. But that can directly affect the power module life expectancy. Some other online resources that we have on the Emerson World is the System Engineering Guide. If you folks are having trouble sleeping at night, I'd highly recommend this Emerson Wireless Security document. It's about 500 pages long, and if you make it through 3 pages, I'd be shocked before you're nodding off for the night. So I highly recommend that one. We also have the online planning tool as well, so it gives you a really good idea on network capabilities and so forth to help design your overall network. Okay. A little bit on the gateways itself. So currently we have 2 gateway formats. One is a DIN rail mount unit that fits on a 35 millimeter DIN G rail. It's basically about the size of a small notebook. And that's our DIN our 1410 S1 version. So it's made to go back in a panel. That is an ideal scenario because we're doing PoE on this, or possibly, or if we're feeding a 24 volt power supply to it, all that infrastructure, including output of the gateway itself, whether it's Ethernet or HTTP IP, all that infrastructure is in the back of the panel, so that's easily installed. There's also a field mount version on that can be, it's a ruggedized housing. It can be installed in the field, class 1 div 2 area. And you'll see on the right-hand side of that, it's made to integrally mount to the Cisco IW6300 access point. So a lot of our customers have remote areas where they'll want to do wireless backhaul. So we mount our gateway on that IW6300 directly. We take the WiHart field device signals into that, puts it onto the WiHart or the Cisco access point, and seamlessly sends that wireless backhaul to another access point at the plant and back into your infrastructure. So quite a nice option if that scenario presents itself for a wireless backhaul. Some of the other things we get into is we now have dual network capability on each of these antennas. We were previously limited to 100 devices on our first launch of our gateways, and we were also further limited to 50 feet of coax connection for that antenna type. So now with these new designs, we can not only do 200 devices per network, we can put 2 networks into 1 gateway. So 2 antennas, 1 antenna per network into 1 gateway, up to a total 400 devices. So it presents a bunch of different options that we didn't have with the gateway prior. The first hurdle we always came into when we run into implementing wireless in a customer site is gateway location. But because now we have this long run of cable on the antenna side up to 400 meters away from the gateway itself, we can more easily locate the gateway location and then simply run the Belden 3084A cable out to the middle of your wireless infrastructure, for example, to make that as easy as possible for your implementation. It makes it much easier and smoother and takes a lot of the worries away from it. So same with a smart antenna, 400 meters away, and it's backwards compatible to a couple of our older gateways as well, which is nice. Installation guidelines, I mentioned the 1410S1 DIN rail. It's a class 1 div 2 on device, DIN G rail, 35 millimeter. Anybody familiar with our pressure transmitters? That bracket that's on the 781S mounting is included with that antenna. Very versatile bracket, can mount it on a pole or a standard above a roof line, for example, or even to a wall if need be. So a very versatile bracket. Also makes great shelving brackets if you need a shelf in your garage. 1410S2, as I mentioned earlier, it's a field mount unit, and it uses the same 781S antenna. New to the portfolio, when we have these long runs of cabling, we now have the capability of running a home run cable of the 3084A cable, straight run without any J-box in the field. The first antenna design had an integral 30 feet of cabling, so we automatically, any further than that, back to the gateway, we were forced to use a J-box. So this enables a full run 3084A Belden cable out to that gateway location, and it's field connected, as you see on the terminal there. Basic wiring. So you'll see power. You'll see 2 connections for your antennas if desired, and also 2 Ethernet ports. Okay, so lots of options there for configuration. We also can do redundant gateways as well, if that is a requirement for our customers. A little bit of look on how the gateway interface looks like. It's as simple as putting in the IP address for the gateway. Default is 168.192.1.10. It pops up a web browser interface, and this is what you see typically on the web browser itself. So on the left-hand side, you see a quick snapshot of how many devices should be on the network. This one's typically is saying 400 should be there. There's 399 live. So 1 is unreachable for whatever reason. It may have fell in a pond, somebody stole it, or the power module may be totally dead in that unit, and you have to further investigate it. One of the nice options is it further tells you any devices that have power module voltage drop to a certain level. That will enable you to change out that power module before it drops off the network and becomes an issue. A little bit on wireless security. So obviously security means just the same as our everyday banking. We tap our phones to pay from our Google or Apple Pay wallets on our phones. We expect security. So that same type of security and the data transfer is built into our gateways. So it works on the 2.4 gigahertz. It's designed into the protocol right off the bat. So security on its own, I remember when I first got into the selling gateways and wireless protocol, we were chasing a wireless backhaul project at TransAlta in Sarnia, and it included Cisco access points. So I enlisted the security expert from the Emerson side. We spent 3 hours just talking gateway security. So I'm not going to get into that, obviously, but there's a whole bunch of wireless security pieces that the IT folks are very interested in hearing and making sure that they are in an okay scenario for devices to come in. So basically, anything on this wireless network, field devices, the gateway itself, and of course the data that gets sent from the gateway to the DCS. That is the most important part, that it remains secure. There's no USB connections on the devices themselves. Even if you connect up with a Trex handheld, you cannot see the join key and network ID. You have to generate that from the gateway itself. So there's built-in security even at the device level to take care of those issues. And when we get into the gateway itself, the transmission of that dataway, it's a non-routable base protocol. So there's no IP address associated with those field devices. And it's AES 128-bit encrypted. And it's also got Achilles rating that is a high-level security rating that is applied to wireless devices. So it meets all those scenarios. And like I said, there's built-in security right from the start in these gateway scenarios. So including role accessibility. So you can limit the managers to a read-only, for example, and let the real people be able to get in there and do configuration as required. So right from field network, gateway, and our data out into the DCS or Historian, or even as simple as a web browser, that's all secure all the way through. So a little bit on, there's a little bit of extra sleeping material, I'll call it, on the website if you want to go in and see that as well. You can do a Google search on that. Emerson WiHart Security, and you'll come up with those documents. Product overview. So a lot of our customers are currently looking to add measurement points in their plants that may be traditionally cost prohibitive. Running wire, CRN, TSSA all tend to be headaches when you want to do a new installation in your plant, whether it be a pressure, a flow, or even a temperature point. Excuse me, they can all be problematic when you go to add these. So a lot of our customers are running into, they're running out of I/O. So analog inputs on older control systems are at a premium. So when they add wireless devices, you simply get away from a lot of the conventional, traditional engineering and drawings and so forth that come with those type of projects. Really on the wireless side, you do the hookup drawings, its connection to the process, and that's it. There's no obviously wiring diagrams, analog inputs, or anything associated with those type of devices coming back to the gateway and ultimately to the control system. So predominantly these are for monitoring applications. We can do very simple control, but normally it's for monitoring. So a lot of our devices are enabling you to eliminate costs, reduce the complexity on projects. We even have customers that temporarily install devices, whether it be a temperature or a pressure device, say to do hydro testing on a new line being put in the plant. You can well imagine wiring and leaving those devices over a 24-hour period to do a hydro test on a pressure on a new pipeline, for example, is cost prohibitive. It's expensive, so they can easily install wireless devices and get those done. So we can do accommodate change. We can add a device where cost inhibited it before. Safety is another reason why customers are implementing our products, and overall reliability, because we can give them those measurements they never had before to make safe decisions and make their plant run more reliable than ever. So you can see here we run into basically process monitoring, pressure, temperature, level, and flow for the most part. And then we get into the reliability world where we're looking at vibration and PRV liftoff and so forth. Gas monitoring for perimeter monitoring on a plant. Stranded diagnostics is another one. So we basically cover the gamut for the process monitoring and reliability. A little bit into what we refer to as non-intrusive measurements, where we're not penetrating the pipe or we don't need access to a tank, for example, to make a measurement for you. So those include X-well. I'll go into that a little bit as well. Erosion and corrosion, where we're continually monitoring the wall thickness of pipes, for example. 708 acoustic comes into steam trap monitoring and PRV applications. Vibration, pumps, motors, fin fans, cooling towers, all that fun stuff. Anything that's rotating, we can basically put that AMS vibration transmitter, often referred to as the 9530 in those applications. New to the Emerson portfolio the last year and a half or so is Flexum ultrasonic. So this is an ultrasonic clamp-on flow meter that goes on the outside of the pipe to very accurately measure flow within that pipe, obviously. Okay, so our products run the gamut. There isn't there's a few holes, but for the most part, everything we do in the wired world, we have a wireless offering as well. The other nice thing about that is it uses the same tools. Because it's wireless HART, a lot of our customers have infrastructure, whether it's a handheld or software they're currently using and training to use those wired devices. When it gets into the wireless world, no new tools, no new training as far as those devices are actually applied and maintained. So no big learning curve when you drop these new devices into the plant. So we have wireless pressure. I'll do a little bit on the pressure gauge here in a second. So this is a neat product where we're replacing mechanical type gauges, Borden springs, in a mechanical gauge. So when a mechanical gauge gets overpressured, it will never return to the same spot. It basically becomes inaccurate and gets thrown away. The other thing that happens with mechanical Borden springs is they get blown out. So there's a safety aspect. The burst pressure of the Borden spring has been violated, and liquid process or gas process can be emitted from that gauge itself. So this wireless pressure gauge takes care of a lot of those process and safety application concerns away because it's got a pressure module in there. So it's isolated with a couple barriers. It's got overpressure protection. There's a lot. I recommend going to the Rosemount YouTube channel for a variety of different reasons. But on there, you will see a wireless pressure gauge where they have a 0 to 5 psi gauge. They're applying 2.5 pounds to it. So dials dead center. They overpressure that gauge 3 times to 720 pounds and bring it back to 2.5 psi every time. You can't do that with a mechanical gauge. It just simply it will not be repeatable after it's overpressure. So into the temperature world, we have several different temperature products. Single inputs on the left, you'll also see X-Well noted at the bottom. I'll talk about that in a little bit here as well. We have a low tier 248 wireless. And the one on the right is the 848 wireless transmitter. That'll take up to 4 inputs. So a combination of thermocouple or RTD inputs. And the idea with that is if you have closely mounted RTDs and thermocouples, you can reduce your cost per point considerably when you can take those thermocouples or RTDs into one transmitter rather than 4 individual. A little bit on the X-Well technology. Again, this is part of our pervasive, non-intrusive temperature measurement, where traditionally, when you design a thermal well, there's a whole bunch of considerations you have to take into effect. You know, your T-well length, the mounting style, material, wake frequency is a huge one. So wake frequency, for those that may not know what that is we do a wake frequency to basically do a calculation on how much forces of flow based on viscosity, pressure, and flow rate, of course, before that thermal well may be in jeopardy of breaking off. So very important. You don't want a thermal well end up going through your turbine. Trust me, that's not a good scenario. So we've come up with X-Well technology where we enter the pipe schedule, pipe diameter, and pipe material. We insulate 6 inches before and 6 inches after to reduce the stem temperature influence to very accurately measure the flow of gas or liquid in a pipe. So we can make that measurement very accurately without penetrating the pipe. A lot of customers are installing these temporarily, outlet of a pump across an isolation valve, for example, to see if it leaks. Customers are coming up with their own applications to apply these. We get into our level portfolio for wireless. So world's only 3308 is the only true wireless guided wave radar on the market today. Just like the only wireless 2160, there's a typo on this slide, vibrating fork, which is a point level device that will wirelessly send back an open or closed scenario, and the 708 acoustic transmitter. So a little bit on the acoustic transmitter, there's also a temperature sensor in there, as well as the acoustic. So some of the applications that we get into on these are steam trap monitoring or PRV liftoff. You can well imagine if we have a a PRV on a steam vessel, and we have a liftoff. Obviously, it's going to make a lot of noise when that relief valve lets go, as well as there will obviously be a big temperature shift as well when steam gets vented through that piping system downstream. So that temperature and acoustic are combined to be able to advise customers when and how long their PRV has been opened up, and even more importantly, in a lot of cases, when it reseats. Very common issue with safety and relief valves is chatter. They'll sit there and not fully reseat. So this is another way that the 708 can help operations not waste steam or any other process gases, for example. 705, so we can put this on to bring totalizer information, primarily off of a mechanical turbine flow meter. And then we get into 928 gas monitors. We're limited to right now H2S, O2, and carbon monoxide, but LEL is under development. I just heard yesterday actually that product should be on the market for early next year. It comprises of an electrochemical sensor that get pre-calibrated in the shop. So you have a wireless device in the field. This plugs into the bottom of the 928 wireless gas transmitter. So there's no back and forth with the calibration requirement. You just take the pre-calibrated module, plug it in on the outside transmitter, and away you go. Some of the other interesting applications and products that we have are the 702 and the brand new 802. So you'll notice that 802 box is very similar to the 848. It is, same enclosure. But what we have inside is the capability to take up to 8 discrete inputs. These are primarily designed for MOV operated valves. So are they open or are they closed? Are they open and closed when they should be? And this would provide feedback for operations to maintain safety or for operation reasons on an isolation valve, for example. So very important, exciting product. And we can do both ways with this. Inputs from a variety of different devices, whether it's a pressure or temperature switch, a level switch, any proxy switch, mechanical, that type of thing. Or we can do outputs to turn on a horn or a visual beacon for safety for plant personnel. So a bunch of different applications for that 802, and customers are gaining a lot of interest in that product since launch. I'm not going to touch much on this one here. We do have online corrosion and erosion monitoring, and a little bit on the thumb product. So a thumb is available as an option where customer may have a traditional 2-wire loop-powered pressure transmitter, for example. We can install a thumb. It's loop scavenging, and we'll pull the heart variables off of that particular device, including diagnostics in some cases, depending on the device, and sending it back to the gateway as well. So stranded diagnostics, radar curves, initiating some of our fancy things we do with Coriolis and our level transmitter can all be done wirelessly with the addition of that 775 thumb adapter. Vibration side, so we have a 9420 and a 9530. Touched a little bit on that earlier. 9530 is an interesting product. It's about the size of a Red Bull can. So that allows you to magnetically mount or epoxy mount in very small locations on pumps and motors where you actually may need to be. So neat product. We literally sell hundreds of them at a time. Low cost vibration and temperature data back to the gateway. Going to talk a little bit on, Trex. So Trex handheld, you'll see that's a reliability product, but really that's our main tool, if you will, to configure not only wired devices, but all of our wireless devices as well. So it's intrinsically safe. You can use it in Class 1 Div 1 environments, and it actually does field configuration troubleshooting. So that is a main tool for our customers to use. A lot of our larger all of our larger end users have one Trex or several for the plant. A little bit into Plantweb Insight. It's basically supervising software that allows continual monitoring. You can set alerts, but the idea of it is to give you one central dashboard that you can quickly look at. You see red, yellow, or green on that particular asset. So it not only tells you, hey, I've got a problem, it would be red. I've got yellow, I've had a device level alert, something is over the normal parameters in the system. So it flags it as, hey, I potentially are going to have a problem. Or it's green, I'm happy and healthy, no problem. From this software, you can generate maintenance tasks, fire off emails, and assign work as required. But the idea of it is you don't have to be an expert in that particular asset, whether it's monitoring a pump or a steam trap, for example. It allows you to get that data, and you do not have to be a subject matter expert to do that analysis and work with that data. So very powerful software, and we have lots of customers that implement this product. So allows you to see, decide, and then act, basically, in a nice condensed dashboard, and lets you not eat up a lot of your day while you do this analysis of your product. So like I said, seamless integration, minimal configuration to get you up and running. You can also put in traditional wired devices as well as part of this Plantweb Insight integration as well. Various aspects on this, we can hard IP, OPC, Modbus into the data analytics, and then from there, out of there, we can go into the dashboard or another host. So there's a bunch of different options when we get into this scenario on what you do with the data and how you handle it. There's a snapshot on kind of a few of them that are available today. They're really high value on the human-centered design. So when you look at these platforms, it's visually appealing. You can easily pick out problem devices without too much effort. The way you navigate the applications are quite interesting. And this human-centered design is an aspect on a lot of our software to make things go quicker, make sense when you wander through your configuration and so forth. So to make your day goes as easy as possible. All right. So one of the applications that I'd like to highlight is using our wireless pressure gauge. So this pressure gauge, as I mentioned earlier, can replace mechanical gauges, but this is one that our customer had come up with for cal gases on GCs. So you see in the photo up here a bunch of Emerson GCs that require cal gas. So this is always a problem when cal gas is gone and you can't do a calibration. So addition of a wireless pressure gauge allows you to maintain and be advised when the pressure of your cal gas sample gets depleted and you need to change out the tank. So kind of an interesting application that customers have come up with. Again, on the pressure relief valve, we can do pressure on the inlet side of that PRV, or put the acoustic 708 to monitor acoustic and temperature variations on the outlet of a safety or PRV. So very simple application. Similarly, on heat exchangers, we're monitoring a bunch of different points wirelessly and able to calculate the efficiency or the inefficiency of that particular heat exchanger. So very powerful tool, a lot of data that comes into operations to make those decisions on when to take a heat exchanger out of service, for example. A lot of pump applications as well, where we're monitoring pressures and temperatures and vibration. So there's been customers make up a specific crash cart. So say a pump is cavitating and giving them grief, they'll set up wireless devices with a crash cart gateway in a portable cart scenario, install these devices, do a data capture for several days, and hopefully find out the issue. Why is that pump cavitating? Why is it vibrating too much? Is it going to bounce off the mounting pads and be into the street by tomorrow? That type of thing. So a lot of monitoring data helps those decisions. Again, same thing for valve health app. So we can put a DVC on a sliding stem or rotary control valve and allow you to get maintenance data out of that particular asset. So this is probably the latest Plantweb Insight app that's been on the market. So customers are adopting that as we move forward. So I think I'm right on time, amazingly enough. I don't think I've ever been that way before, but that basically the end for me. Thanks very much. And is there any questions?
Yep. Okay. Yeah. So we have a few questions. First question is just, would it be possible to obtain and share slides with us for this presentation?
Yeah, for a small fee. Yes. Yeah. No.
And how much is that small fee?
I plan on providing that to Jonathan. Yes, afterwards. So, Jonathan, I imagine you can disseminate these to the attendees.
We can definitely share this with the attendees.
So the first one here, Kevin Farley, how is device impersonation blocked? Okay, so I don't think you're talking about the device side on that, more on the gateway. So there are that project that I mentioned that we did with the wireless backhaul, Cisco access point to Cisco access point, connected to the gateway. In that scenario, with your access points, they actually had installed a WIP system. So intrusion prevention, wireless intrusion prevention system that continually monitor RF signals in the area to detect attacks. So the device level is taken care of. It's the field network, if there's any scenario with the Cisco access point where that comes into play. Kevin, you have another question here. All antennas are omnidirectional. No, all of our options for the antenna selections are omnidirectional. And the reason for that, especially when we're inside a building, is we want that signal to be directionally sent everywhere. The reason for that is once we're in a building, that signal just continues to bounce around and stays within the confinement of that. So that omnidirectional antenna comes into play in that scenario. So key environmental factors, I assume that means RFI and EMI, rain, sleet, snow, all that stuff. So what happens in the gateway is I mentioned that it's self-organizing in the sense that it will advise which best pathway based on signal strength and signal reliability to get the data back to the gateway, whether that's a direct connection or through another device. So that gateway handles that network supervision and control over what devices go where to get that data back. Good questions, by the way, Kevin. You're at 3 already, so you're at your limit.
We do also have a question on the chat that says, can you talk about the interference by other devices in the 2.4 GHz band, so like microwave ovens, laptops, phones, things like that?
I'll address that one in a minute here. I got some other ones here. Environmental factors. Okay, I did that one. WiHart have an arbitration process similar to CAN to prevent crosstalk. I'm not sure what CAN is, Kevin, but basically, because we enter a join key and a network ID, that will point to a certain gateway. So I've done testing where we have two devices side by side on the table, going to 2 gateways that are side by side on the table, and there's no crosstalk or interference in that scenario. So that's all done with the network control, network ID, and join key for that particular device to get into the gateway. How does WiHart ensure reliable communication environments, high interference? So I think that's similar to the other question in the regular chat side. So in our experience, we haven't had any scenarios where ambient weather conditions, for example, come into play and become interference with our signals, including high EMI and high RFI scenarios. So those are all done with the testing, and we meet those specific RFI and EMI standards on our field devices, just like we do on our wired. What kind of analytic tools are available for monitoring? So again, there's actually a Plantweb Insight application that will monitor wireless or your network health. So there's a Plantweb Insight for that as well. Okay, so what are the common challenges faced with wireless HART deployment? The biggest one has gone away with the new gateway designs, and that was gateway location. That's typically the biggest hurdle that has been made a lot easier with the latest release of our most recent gateways. Okay, so cybersecurity on that, it's password protected. So a lot of those gateway access is controlled by a firewall, no different than your LAN system would be on your plant networks. Any communication delays with this method? I'm not sure 100% what that one means, but basically we predetermine the broadcast interval in those scenarios. Any recommended maintenance inspection intervals? It depends on the device itself. Maintenance would be no different than a wired transmitter. In that case, you're going to have to zero, you're going to have to check the calibration. So a lot of our wireless devices require the same periodic maintenance, just like a wired device would be. What redundancy or fail-safe mechanism built into safe power modules? Great application, or great question. So I didn't mention this earlier. Bad on me, my fault for that. Is our power modules are keyed. So they will only go into the device one way. And the reason for that is if you're in a class 1 div 1 explosive environment, you don't want to mismatch the polarity or cause a spark by dropping in the battery. So those power modules are keyed and will only go in one way into that device. Yes, I will share the slides. And can you talk about interference by other devices? Yeah, so I have not seen or heard that there is any other direct interference in that 2.4 gigahertz band. I think your question is based around that's a pretty common open frequency, and I agree. So what happens and I didn't dive into it based on time, but there's 15 channels within that WiHart 2.4 gigahertz band. So if there's interference that start to get jammed up on some of the channels, you have the option to block them, or if that's not or the gateway will automatically shift channels in that, and if that doesn't work, you can block certain channels for the gateway to access. So I've done that before just with a simple RF frequency analyzer. We had a customer that was thought it was a great idea to install a 2.4 gigahertz wireless access point right within a foot of our gateway antenna. So they were having lots of problems with the devices dropping in and out. So we showed up, did a quick network analysis, found out that they were using up a lot of the channels in that 2.4 gigahertz. We asked them to do two things: change their wireless plant network to 5 gigahertz. They refused. So what we went back in and did is we did an RF analysis and saw what channels were getting jammed up and just blocked those channels from the gateway from accessing. So there's that type of flexibility and configuration parameters that are available in that scenario. Any other questions?
There's a few, like, does the use of wireless HART affect the wave transmitter calibration?
Oh,
Yeah, Roland, a few questions were added as you were answering the
Yes.
first set of questions, if you're looking on your screen there.
Oh, yeah. Okay, so I just got there. So which question did I miss? Sorry.
Sorry. Yeah. Okay. We can start from the most recent. So the first one is, does Emerson or Lakeside provide any wireless training?
Oh, yeah. Okay. Sorry, they're at the top, the newer ones. Okay, so does wireless HART affect the transmitter calibration? No, absolutely not. We use the same tools to calibrate a wireless device as we would a wired. Does Emerson and Lakeside provide wireless training? Interesting question. Yes, but there isn't a whole lot of training that typically is required for our major end users because of the tools they already have and are familiar with calibrating and configuring our wired devices. There's not too much to learn on the wireless side. Any training that's typically involved is out of the gateway. What options do we have? How are we going to implement that data into our existing host or data historian, for example? So that is the piece that gets basic training. Other than that, we just do basically talk about how WiHart works, what we have availability for product, and where they can be used.